So this is question 4 from chapter 4 worksheets. The combustion of ammonia produces nitrogen monoxide and water. So first step, you want to write the combustion reaction of ammonia and you want to balance it. So any combustion reaction, that's the reaction of your compound with oxygen gas. So NH3 reacts with oxygen gas. And from this reaction, it tells us that nitrogen monoxide and water is formed. Now to balance this is gas. To balance this, you're going to need to have 4 ammonia, 5 oxygen, 4 nitrogen monoxide, and 6 water. Now part B. If 8.5 grams of ammonia produces 4.5 grams of nitrogen monoxide, you want to find the percent yield. So percent yield is defined as the actual yield or experimental yield divided by theoretical yield times 100. Now, actual yield is given to us. We already know that our actual yield is 4.5 grams. In order to find the percent yield, we need to find the theoretical yield. Theoretical yield meaning that if 8.5 grams of ammonia combust completely, how much nitrogen monoxide we would expect to get. So our plan to solve for this is from the mass of ammonia, you want to find moles of ammonia, and from moles of ammonia you want to find moles of nitrogen monoxide, and once you have moles of nitrogen monoxide you want to find mass of nitrogen monoxide. So we start with 8.5 grams of ammonia. Now each mole ammonia is 17.04 grams. And now based on the balance reaction, each 4 mole ammonia produces 4 moles of nitrogen monoxide. And to convert to mass of nitrogen monoxide, we know that each mole nitrogen monoxide is 30.01 grams. Now in terms of units, grams of NH3 cancel out. Moles and moles of NH3 cancel out too. Moles of nitrogen monoxide cancel out. So we end up with mass of nitrogen monoxide, and that's what we were aiming for. So when you solve this, you're going to end up with 15 grams of nitrogen monoxide. Now to find the percent yield, that's going to be the actual yield, which is 4.5 grams, over the theoretical yield, which is 15 grams, times 100. And that will give you 30%. Now let's look at part C. If the reaction will proceed at 29.8% yield of nitrogen monoxide, how many grams of ammonia must be made to react with excess oxygen to yield 70.5 grams of nitrogen monoxide? So again, let's first of all write the equation for percent yield. Once we have the equation, it would be easier to see what we're solving for. So percent yield is actual yield divided by theoretical yield times 100. Now let's see what's given to us. We know that our actual yield is 70.5 grams. We don't know what the theoretical yield is, but whatever that is, when multiplied by 100, that gives us 29.8%. Now, from this equation, if you rearrange this and solve for the X, which is the theoretical yield of nitrogen monoxide, that would give you 236.6 grams of nitrogen monoxide. So this is the theoretical yield of nitrogen monoxide that needs to go in this equation. Now, question is that if you want 236.6 grams of nitrogen monoxide, how many grams of ammonia must be made to react with it? So from the mass of nitrogen monoxide that we just found, we want to find mass of ammonia. So obviously we can't do this in one step. We're going to do this in multiple steps. So from mass of nitrogen monoxide, we're going to find moles of nitrogen monoxide. And from the balanced reaction, you find moles of ammonia. And once you have moles of ammonia, you're going to find mass of ammonia. Now, let's start with the mass of nitrogen monoxide, which is 236.6 grams of nitrogen monoxide. We know that each mole nitrogen monoxide is 30.01 grams of nitrogen monoxide. And then based on the balanced reaction, each 4 moles of nitrogen monoxide is produced by the reaction of 4 moles of ammonia. And now to convert this to mass, each mole ammonia is 17.04 grams of ammonia. Now, in terms of units, mass and mass of nitrogen monoxide cancel out. Moles and moles of nitrogen monoxide cancel out. Moles and moles of ammonia cancel out too. So in terms of unit, we are on the right track. We end up with the mass of ammonia. And once you solve for this, the mass of ammonia is going to be 134 grams of ammonia. So what this means is that we're going to have to start with 134 grams of ammonia in order to get to 36.6 grams of nitrogen monoxide. Now, in reality, we do start with 134 grams of ammonia. However, we end up only with 70.5 grams, which would give us a yield of 29.8%.